go to logarithm properties. Now, logarithms have different properties than other functions. These are because they are derived from exponent properties. So we need to be very careful when dealing with logs because these properties that we're going to go through are the only things that we are allowed to do to logs. All right, so my first property, log base a of 1 is 0. So if I have log base 17 of 1, again, whatever the base is, I'm taking a log of 1, so I get 0. Log property 2, log base a of a is 1. So here, the log base and what we're taking a log of are the same. So if I have log base 30 of 30, those 30s are the same. And so I will get out just 1. My next property is called the product rule. And this is where they're going to start sounding a bit weird. If I have the log base a of numbers that are multiplied together, to pull it apart, I add the logs. So log base a of x plus log base a of y. So if I have log base 2 of 3x, I'm going to expand that as log base 2 of 3 plus log base 2 of x. Again, note those bases are the same, and now they are added. Now, at this point, we can go both directions. So going the opposite direction, my instructions are to write as a single log. Now, we do have to check that both of these have the same base. Since they do, we can combine them, though. And so I will write this as log base 3 of 4 times y. Now, one common mistake that people make, if you have the log of a sum, as we have here, this cannot be expanded. I can't write that as log base 4 of x plus log base 4 of 5. That's not what my rule says I can do. So if we have this, there is nothing I can do. I have to leave it as is. Let's scroll this down a little bit. My next rule is the quotient rule. So now I have log base a of x over y, and I turn that into log base a of x minus log base a of y. So log base 5 of 3 over x, I can write as log base 5 of 3 minus log base 5 of x. Now, here's one thing I always want to remember here, which is I can write my terms in whatever order I like. So I could leave my answer like that, but I could also write negative log base 5 of x plus log base 5 of 3. That's just as valid. The way I like to think of these, if the number comes from the numerator, so here the 3, then that log, no matter where I write it, is positive. If the number came from the denominator, so here the x, no matter where I put that log, it will be negative. But other than that, I can write those terms in any order I like. So as I go the other direction, so again, I would like to write as a single log, negative log base 6 of y plus log base 6 of 10. So we know we've got log base 6. Because the log of y is negative, the y is going to go on the bottom. I can draw that y, there we go. And because the log base 6 of 10 is positive, I'm going to put the 10 on the top. So again, if the log was negative, that term goes on the bottom. If the log was positive, it goes on the top. And you'll notice there is no plus or minus now. Those plus and minuses just tell us where to put the term. My next example, once again, this is a common mistake. If I have the log of a difference, just as with a sum, this is something I cannot expand. That would be my final answer. There is nothing that I can do with that. Let's scroll down a little bit further. Next, I have my power rule. Log base a of x to the r power, I'm going to pull that r out in front as multiplication, as a coefficient. So if I have log base 8 of x squared, I pull the 2 out in front and get 2 times log base 8 of x. Once again, we would like to be able to go the other direction. So if I have 4 times log base 7 of y, I get log base 7 of y to the 4th. Now, my next property is actually just a combination of the one I just hit and the second one, but because we see it so often, we do write it as a separate property. So log base a of a to the r, you could think I pull the r out in front to get log base a of a, but log base a of a is 1, so I do just get r out. Now, remember, if you see just log and no base, I understand that to be log base 10. And at that point, I can see that the base and what I'm taking a log of are the same, so they undo each other. The entire log goes away, and I do get just x. My 7th and final property, we don't see this one quite as often, but I would like to hit it. A to the power of log base a of r is r. Again, note those bases are the same, and that's why it cancels out. So if I have e to the power of the natural log of x, remember the natural log is log base e, so I can see the bases are the same, and I will get just x. So these are our log properties. Again, these are the only things that we are allowed to use with logarithms.